Okay, these are the section 8.3 notes, inverse trigonometric functions, page 10. This really is the last page because pages 11 through 14 just have examples of the graph, and those are there for your reference. Okay. So now we're talking about a composition of trig functions, and sometimes it's a little tougher. Sometimes you can stick them into the calculator. Sometimes it doesn't make quite as much sense as if you can draw a picture and work through this. So we're going to start with the picture because we do want an exact value if possible. So inverse sine of 3/5. First off, 3/5 is positive so that we know that that sign is in the first quadrant. Okay. And so keep in mind what this means. If it says inverse sine of 3/5 equals, we can call it theta. That means that the sine of theta would be 3/5. Okay? And so we are going to draw this triangle in the first quadrant. We're going to label theta. And then the opposite side is 3, the hypotenuse is 5, based on that ratio of 3/5. Okay? So I guess I should fill in, we'll give it a minute. From there, we can find x. We got x squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. X squared equals 16, so we get an x equals 4 there. Okay, and I'm going to use that to fill this in. X equals 4, y equals 3, r equals 5. I guess I should fill in the top. Domain of inverse sine is -1 to 1. So like I said earlier, if our inverse sine is positive 3/5, we know we're in quadrant 1, and that's how I drew the triangle. Okay, and so now, just to have our thinking straight, we are looking for the cosecant of the inverse sine of 3/5. Look at how I labeled it up here. Inverse sine of 3/5 is theta. So I'm just going to substitute inverse sine of 3/5 with a theta. Now I'm looking for the cosecant of theta. Cosecant is 1 over sine, or hypotenuse over opposite. Hypotenuse, opposite. And so we get 5/3. Okay, 27. The sine of inverse tangent of -2. So the domain, let's fill this in first. Domain of inverse tangent is -infinity to infinity. So we're okay. If the inverse tangent is negative, we know we are in quadrant 4. And so that's how I'm going to draw this. Here's my triangle in quadrant 4. Here's where my theta goes. So I've got inverse tangent of -2 equals some theta. That means that the tangent of theta is 2, which we could write as 2 over 1 because we're talking about ratios here. Tangent is opposite over adjacent. So from theta, our opposite side is 2, our adjacent side is 1. I have not drawn a fabulous triangle that fits, but it doesn't really matter. So now we need to find r. We've got 1 squared plus 2 squared equals r squared. 1 plus 4. R squared is 5, which means that r is the square root of 5. And so we're going to fill this in. X is 1, y is -2. We're in the fourth quadrant. R is square root of 5. So now I'm going to do the same thing I did up top. I want the sine of the arctangent of -2 arctangent of -2 we're going to call theta. A lot of people are rattled by the fact that we don't actually know what theta is. It's more of a placeholder here. We can use the ratios to label a couple sides of our right triangle. We can find the other side, and then we can find what we're being asked to find. And so sine of theta, opposite over hypotenuse, 2 square roots of 5. We don't like that radical in the denominator, so we are going to rationalize. We get 2 square roots of 5 over 5. Number 28, the domain of arcsine, inverse sine, is -1 to 1. Here our arcsine is negative, so again we're in quadrant 4. And so here's our theta. Remember, if inverse sine of -1/4, we're going to call that theta. That means the sine of theta is -1/4. We're in the 4th quadrant, so we know that this is opposite. This is our hypotenuse. Our y is going to be -1. Our r is 4. We can solve for x. I get x squared equals 15. So x is the square root of 15. We are not worried about changing that to a decimal at all. We prefer the exact form. And so let's go ahead and substitute that back in. I want the cosine of the arcsine of -1/4. We called the arcsine of -1/4 theta, so we're looking for the cosine of theta, which is, I guess I should have labeled this side, adjacent over hypotenuse. We get square root of 15 over 4. And that one's done. Okay, so 29, 30, and 31, we are going to plug these all into the calculator. Please make sure that you are set to radians. The sine of the inverse cosine of 0.8324 is 0.5542. The secant of the arctangent, so that is 1 over the cosine of the inverse tangent. We get 4.9412. And the cotangent of the negative inverse sine of pi. So if you try to plug in inverse sine of pi, you're going to get an error. Because inverse sine has got a domain of -1 to 1. Pi is roughly 3.14, so it lies outside that domain. So none, because pi is not a member of our -1 to 1 domain. Pi is bigger than 1. And that is it for the 8.3 notes. You can review the pictures of the graphs on pages 11 through 14. Definitely let me know if you have any questions.